Secure Digital Life. Can you believe it already? And you ask for it, you're going to get it. You wanted to see Wireshark. Today, you're going to see Wireshark. Stick around.
This is a Security Weekly production.
Welcome to Secure Digital Life. And you type in AAA porn or whatever it is you're typing in. I'm sorry. I was at a PG show.
And I'm really excited to be here.
I'm glad you're here because somebody needs to know what's going on.
That's right.
Okay, so
now somebody has to drink this.
I think it's another day. It's another episode.
Yeah, he's looking at the wrong camera.
You put my camera over here. Cut. Basically, forget you ever saw that. I think actually forgetting you ever saw that would really be a good idea at this point. Hello. I'm back from... I can't point to myself. It's like one of those childhood things. Yeah, thank you. See, from B-Sides, Connecticut, which had white shirts. So feel free to project all kinds of things onto this with CGI. But we were all at B-Sides, Connecticut on Saturday, and there was a huge crowd of people that were there. So everything was fun, and we did lots of hacker movie trivia, and we did a bunch of interviews. And I hope that you'll get to come to the next one. And speaking of the next one is Providence HackCon. And Providence HackCon is on October 21st at Roger Williams University and the Providence Public Library downtown. You do have to register. It was primarily for cyber patriots. But, hey, if you're a aficionado of our show, if you get in touch with us, we can help you out with connecting with that particular con, which is going to be on the 21st. Congressman Langevin, who is the Congressional Cyber Caucus leader, is going to speak. We got a bunch of great guests coming in that Paul and other people have put together. So it should be lots and lots of fun. After that, the Wild West Hackin' Fest in Deadwood, South Dakota, which is coming up on the 24th of October. So we'll be there as well, and so you should definitely come and see us while you're at Wild West Hackin' Fest. There's lots of good presentations. They're even going to let me speak, which is kind of a, scary thought. I had to take the swears out of the title of my presentation already, and oof. Yeah, well, we won't get into that. But it was originally called something like Frack College, I'm Certifiable. It didn't say frack, but we'll be nice. So today we're going to start showing you some of the tools that people use for packet sniffing. If you didn't watch the show last time, you might want to go back and watch that. We talked about how packet sniffing works and why people are doing it. Today we're going to look at a tool called Wireshark. And Wireshark is free, which means you can jump on the internet and you can go get it and you can use it yourself. It runs on Macs, it runs on Linux, it runs on Windows, it runs on just about anything. And it's a super powerful, awesome tool that a lot of system administrators are using all the time because it lets you sniff your own network, which sounds vaguely, like something that would be banned by a lot of major religions or something. But nevertheless, you can do that all that you want. And you won't even go blind, most likely. But Russ, who is brilliant, see the brilliance shining off of him.
No.
Maybe that's just the glare from my shirt.
It's the coffee.
The coffee, yeah. Russ is going to actually show us how to use Wireshark and get us started with that. And then in the next show, we're going to take up looking at some more elaborate Wireshark captures that we'll put together. And then if you have new topics you want to see on SDL, you should definitely send them in so that we can get on that. All right? So I'm going to let Russ talk to you about Wireshark.
Woohoo! Hey, everyone. And so as Doug put it, we're doing Wireshark today. I don't want to sound like too much of a Rhode Islander.
Come on.
Wireshark. Yo. Wireshark. No. We're Wireshark. And you can get Wireshark, as Doug mentioned, for free at wireshark.org. Mm-hmm. Notice the big shark in the background.
They can't see your screen, though.
Oh, yes, they can.
Oh, they can
and then,
now,
yep.
Ooh,
and then, you meant
wrong?
a minute ago. Yep. And then, so the big swimmy shark. You can download it. It's for PC and Mac. Do they have one for Linux and Unix? I don't know.
I think there's Linux installs
Let's
for
just
it.
take a look real quick.
I mean, the Mac installs are this. You just install the source code
Yeah,
to
that's
pilot.
right. Yep.
So if you're a Linux user, you can get it working.
Of course. Yep. So
it's a little harder to use in Linux, but there are like Ubuntu distributions that have GUIs. I think they have a GUI for it in Ubuntu distribution.
Awesome. So here's Wireshark. So I just downloaded it onto my Mac. And like I said, feel free to download it on whatever machine you're using. And just to start your first sniff or your first network analysis, we're going to click up here in the little fin icon here on the upper left-hand corner, and we're going to start capturing packets. You'll notice, and you'll notice I've already done one just to test it on the wireless, so I'm not going to save this, just FYI. So I'm going to click on the fin, and I'm going to continue without saving. And we're going to let it run for about 10 seconds, maybe 15, just to capture enough data to take a look at what's going on here. So here we go. Ready, set, and go. All right, so 1 Mississippi, 2. No, so we're just watching. Now you're going to see a lot of stuff populate here.
Right.
Basically, this is a lot of the traffic that this machine now is sniffing out or detecting on the network. So, there we go, blah, blah, blah. And I just want to get, yep, there we go. All right, so I'm going to stop it now. I'm going to click on this red box here, stop capturing packets, because I've got enough that we can talk about. And what you're going to notice here in this top sort of third screen, maybe quarter if you count the bar, is you've got some columns. And the first column is the number, and this would be in which order that particular packet was caught or sensed. Then you have time. And the time here is measured in seconds from that first packet. So first packet was caught at 0 seconds, then 1.02 seconds later it caught 2, and so on and so forth. You can change that by looking at the time display, and you can look at date and time under view if you want. Maybe that'll help you do something, but I'm just leaving it there for now, just for demonstration. So you can change the time. The next is the source and destination. And the source IP is obviously the IP address that the packet was sent from. And the destination is where the packet is going. So if we look at my IP address here, and I'll show you my Mac just while we're at it. So my IP address is 172, ends in 226, okay? And my Mac address is that's what I don't like. Yeah. Oh, what happened? I can't even click off. All right. And my MAC address down here. Oh, look.
10 CB.
Yeah. So
it ends in 10 CB.
Yeah, it ends in 10 CB. All right. So just keep that in the back of your mind. So what we have here is we've got a packet coming from 1.77, which is on the network that I'm on, sending to 1.255. And remember, 255 is not a typical IP address that you would be using on a network. That would be reserved for maybe not the gateway so much as routing, right?
That's a broadcast.
Yeah,
that's the broadcast address for the 172.16.1 network.
Yep.
So when you do see the final address of a network segment, and so again, if you need to go back and watch all the IP addressing segments that we did in the past. You'll see that the last address on a segment is the broadcast. So when you see, in this case, that I can actually probably guess the net mask of that network by looking at the broadcast address. So 255 on 172.16.1 the broadcast would be 172.16.1.255, and that was and you can tell it's a broadcast. You look at the protocol over there. That's a network broadcast name service request. So that's something that's saying I need to find a name of some device.
Yep. And then so after the source and destination, you'll notice that you have a protocol. You've got, it could be TCP, UDP, HTTP, HTTPS, SSDP, ARP, yep, ARP, TLS, and so on and so forth. We're going to look at a couple of those in a minute. And then on the last two columns are the length of address and info, which Doug was presenting earlier. So we've got a lot of good information here. And this is just the overview. And if you scroll down, you'll notice how Wireshark does a great job of color coding a lot of the traffic. You can turn the color coding off by clicking on that. But I kind of like it color coded just because, and you see a sort of coloring over here because you want to look for the stuff that's red because the red is the usual issues that you want to take a look at, like, for instance, reset after acknowledgement. So we're going to look at a couple of those. And, of course, all of these are filterable. So let's say I want to filter out any traffic coming from this 1.57, okay? So let's say I want to filter out some of that traffic. I'll simply click on that and right-click, or in the case of a Mac, double-tap and apply as filter. And since I don't apply as filter, and since I don't have, I'll just use and selected. And now all traffic from 157 is filtered out. And notice how you have that up here, okay? And you can even apply multiple filters. Let's say I want to apply only filters for HTTP. I come up here to where it says add a display filter and just start typing. Notice how it's red. Red means that it can't recognize that particular filter yet. But once I get to P in HTTP, you'll see how it turns green. Just hit enter, and now it's filtered out traffic on the HTTP protocol. Now, let's say I want to add HTTP traffic only sent from .226. So I can, again, right-click, go to Apply as Filter, and choose and Selected. And now both conditions are true, as you can see here. So it's a combinative search between HTTP and traffic coming from 1.226. All right. So now that we've got that out of the way, excuse me. Now that we got that out of the way, let's actually take a look at a piece of traffic.
Can I mention one more filter?
Yeah, I love it. Yeah.
The conversation filter. Right-click on one of those packets there. You see down there it says conversation filter or colorized conversation. One of the really cool things that you can do with it is you can actually have Wireshark chase an entire exchange. So instead of just looking at like a raw collection of packets, you say, I'm really interested in like the conversation between this site and that site. And by colorizing it or actually filtering everything out except that, you can end up just looking at a specific set of packets that are all involved with each other. So then you're just seeing the back and forth between those two devices. And that's something people use a lot when they're trying to capture information, as opposed to just like, doing good things.
Yeah.
Okay, I'm sorry. I didn't mean to interrupt.
No, please do. So going along that, we've got the list of packets that we've sniffed, and we want to analyze one. So let's grab one. I'm going to grab an HTTP packet.
Find a TCP three-way handshake. Come on.
I'm not applying for Google.
No, come on. I see
All right. What do we have?
I see a SYNAC up there. See that one?
Yeah,
go up
here
the top. There's a SYNAC, so that's probably part of a handshake.
Yeah. So here's a part of the handshake, as Doug said. And now I'm going to move to the second third of the screen, which is down here. It gives you some information about the frames that the packet's part of. Just information here about the seconds.
That's the Ethernet frame. So, or actually, that's the header. That's the preamble to the frame. So
awesome. Excuse me, I needed a sip of coffee there. All right, and then what we want to look at here is maybe the TCP information. So if I click on TCP, we're going to get the source port, so 80, the destination port 52,796. We stream index and so on and so forth.
And if you're asking yourself at home why the source port is 80, because 80, we all know that 80 is HTTPD as a web server, because that's the source. Typically, what that would mean right there is that's a reply. So even without seeing other information, that's very likely a reply from a web server that we've requested something to. So. Sorry, I can't help myself.
No, I love it.
And you see, it's a SYNAC there, so that means that this is a response packet. So this is something coming back.
Yeah,
and that's good. That's what you want to see.
Yeah, and just looking more underneath the flags, the SYNAC, as Doug said, we've got some values here.
But you can deep dive these things all the way down to the bit level. So if you want to dig into the packets, literally by looking at the raw binary of the packets, you actually can do that. What Wireshark is doing is taking that packet. Because all the packets are standardized, so if you go on Wikipedia or you just go anywhere, you can find the standard TCP packet. You know what's in that packet content. And because you know what's in the contents, you can actually dig through it yourself. But guess what? Wireshark did that for you, and it's summarizing all that stuff that you're seeing on the screen. So that's how that gets put together. It knows where the contents of these packets are. It knows where the SYN flag is and the ACK flag and and it knows where the data content. So when you see a packet that's got a bunch of garbage in it, as data payload, that's probably an encrypted packet. So it's HTTPS or it's something else that's encrypted. If you see raw data there, raw ASCII data, then that's HTTP, and you'll see some of that as Russ pulls it up here.
Yep, we're gonna look at a raw right now. But for what I will also want to notice is I'm going to move down to the last third down here where you've actually got the bit levels, and notice how over here we've got the $1 and then asterisk 5ZE and so on and so forth. Putting that together, that doesn't really make a hell of a lot of sense. A heck of a lot of sense. And but that might mean that it's encrypted. I mean, it could be somebody with that crazy password, but I doubt it. Or crazy characters like that. But let's move to HTTP and take a look at some of the values that we see. So look at this. Now that's plain text.
Plain text.
Yeah. Look, a comma, nettest server, so on and so forth. So we've got some plain now. Now, if you're transmitting a password in an unencrypted format, a sniffer could catch that.
Oh, yeah.
Right here. And all they would need to do is type in, put these characters together to find out what your password is and type it in. And it gives you the actual address where you typed in your username and password.
Oh, absolutely. So, I mean, that's what you use like a conversation filter for. So if you grabbed a conversation, and I'll use Telnet as an example. We've talked about Telnet on the show before. Telnet runs on port 23, so if you were looking through here and you saw port 23 TCP, you're going, oh, baby, because you get everybody gets all sweaty when they see port 23 Telnet because it is sent in the clear. And that means if you were looking through this very conversation right here, and when I'm going to do some live fire examples for next show, when we see those, I'm going to do a Telnet, and you will see it literally says login because the login information is sent to you from the screen in plain text. And you will see the login information go back the other direction from the person typing. So you would actually have the login and password of that machine. And like Russ said, you would actually have the IP address of the machine and the login and password. So you could just real quickly go out there and log into that device, which is why they tell you don't use Telnet. Stop it.
Now think about sitting at Starbucks and somebody's, a bunch of people sitting there drinking their coffee and on Wi-Fi, right? Now, more often than not, those are unencrypted. They're not secure wireless networks.
Right.
So imagine just some random Joe or Jill sitting in the corner of Starbucks and running a Wireshark. Now, that's illegal, we know, but that's never stopped anyone before. They're getting all of these usernames and passwords transmitted in the clear. So they just have to let this run, output the file to their desktop, go home, and all of a sudden they've got, ways to infiltrate XYZ.
And the other way people use this, just to be blunt about it, is not only can you capture off Wi-Fi, but you can do what is called span mirroring, which is a way that you take a switch, so like a manageable switch, like a Cisco switch, you can span mirror packets from all the ports on the switch and have them all come out one of the other ports is another way to do it. And an even better and cooler way is to take a little $3 hub, not that I ever did this, take a little $3 hub and park it up over the ceiling in front of the router or the firewall, and every single piece of traffic that goes into that hub will come out the other port. And then the network won't even see it. It's transparent, but you're actually sniffing all the traffic. And you would get this giant collection of packets. You need a pretty good, like 4 terabyte hard drive sitting there so you can dump all that. And then you can sort through it.
So let's actually do a real-time capture. I'm going to go to, where are we going?
Go to cyber.rwu.edu.
Okay. So I'm going to stop.
And use my login.
Yep, okay.
Which is, the password is password.
Yeah. I'm going to hit the shark again because we're going to initiate a new sniff and continue without saving. And here we go. So I'm going to open up Firefox, Shazam, and we're going to head into Wireshark Go Deep. All right. Let's go cyber.rwu.edu. Okay, and so it's going to load up cybersecurity and networking for our university, and maybe we just take a look at this and maybe just click.
And remember, all that page information was downloaded, so that was streamed onto your machine before you saw it, which means that it was just raw traffic. And I mean, the web browser's reassembling all those packets, so they come streaming in, they get buffered, and then they get reassembled into the web page. So you should see all that traffic in Wireshark.
And that's what I'm hoping. Cross our fingers. I'm going to hit stop on the Wireshark here, and I'm going to look for HTTP. I mean, I can sort, I suppose.
Should be pretty far down there, actually.
Okay, right here, host rw.edu.
Okay.
Yep,
you found it.
So maybe there wasn't so much traffic going on. But anyway, so we've got under the HTTP GET. Remember, Doug had talked about GET and acknowledge and all that stuff. So we're getting some information from the host, which is the website we went to. But also, and I want to come down here to go to this new thing because it's HTTP protocol. It puts in HTTP area here. Tells you a lot of information, like what browser hit it, what server it was, where it was redirected to. Notice how, because we use a CMS or a content management system, I think it might be Drupal.
Well, actually, that's just a fake out on the node right there. So they put a name up there like cyber.rw.edu, which doesn't really exist, and then it actually redirects that traffic to www.rw.edu.
Exactly, and content management systems use nodes to resolve. So it's pretty neat what you can come up with. You can get IP addresses returned and so on and so forth. So it's really kind of wild and comprehensive, some of the things that you can get.
I think if you just double-click that packet, the one you get the HTTP at the top, if you double-click that one, it will actually show you the whole conversation then, I think. Yeah, so it's actually pulling the entire conversation and that particular transaction together, because you'll eventually down here, you can see down there toward the bottom now, you're seeing what it's loading. And eventually you'll just see the actual, if you get enough of these conversations, you'll actually see the content. I mean, like just the words that are on the web page.
Yep. So it's super cool. There's a lot that you can do with it. I do want to show one other thing. Let's say that you've identified XYZ piece of traffic while you've been sniffing your own network, right?
Yeah, don't do this.
Don't do this elsewhere.
It's
illegal. And let's say that you've come up with something and said, hey, I think this is a nefarious person trying to get in. I want to find out what the source is on my computer and disable it. I want to get rid of it. So one of the things that you can do here is we're looking for RST or reset pieces. And if I can't find one, I'll just choose another one. But I'm looking for black. More black. I wasn't on very long, so maybe not. But okay. No.
Are you looking for like a...
Oh, here we go. There we go. Red.
A reset.
Yeah. So see the reset here, RST, and then it's acknowledged. This is a packet this is a type that indicates that your computer said, oh, I don't want this connection. This is not something that's really good. Yeah, it terminates. This is why it's red. So it's identified something's going on here, something funny. So notice how it's coming from 138.197. I don't know what the heck IP address that is. That's not on my network. That's coming from external. So something is going on, and I want to terminate that connection. So how do I do that? You can do it on a Mac or a PC. I'm going to show you on a Mac because Mac uses Unix as a backend or backbone. So it's and plus I'm on one. So let's try that. So let's see. We've got it coming in from port 443, which is SSL. All right. So I'm going to open up a terminal here. And yes, it's matrix style. And I don't know. Can I zoom bigger? Yeah, sure. Oh, yeah. Look at that.
Yeah.
All right. There we go. Now you guys can see that.
Fat command line.
Yep. All right. So the first thing I need to do is I need to super user. All right. So I'm going to use sudo. Okay. And then what we're going to do is we're going to do lsof. Okay. So give it a list of. That's what that does. We're going to use the I slash and then colon and then what port that we found here.
443.
443. Yeah, so let's use 443. Now, this is going to ask me to put in my super secret password. And now it's going to give me all the traffic on port 443. I'm going to reduce this just a tiny bit so I can fit it on the screen because what I need to show you is that you can get it by the PID. So now what I'm going to look for under the TCP/IP information is that IP address 138.197, and hopefully I'll find it. And I don't.
Yeah, you got a lot of stuff going on.
Yeah, we got a lot of stuff.
I mean, 443 is a really common port, so finding all those.
Yeah.
I mean, essentially what you're seeing here is these are all the connections to your machine, and that doesn't mean anything bad, so don't panic. It's just like running netstat in Windows or whatever.
Yep.
Just because you see things connecting, when you go to a website, there's a lot of connections that are going there. So you don't need to go in and kill all these jobs. But if you did think this job was running, if it was malware, if it was something bad, you may well, like you see those that say established there, these are connections that are running.
That's one right here.
And I see like Amazon AWS, these can be all sorts of things. And you would want to take a little bit of time and think about what these things are and why they might be running before you just dive bomb in there and start killing jobs, because you can, especially on a server or something else, you may break your own connection by doing this.
Yeah, exactly. So let's just identify something here that
I'll just pick one.
Yeah, I'm going to pick one. I'm going to grab this 7. That's established. Let me just.
Oh, that's okay. Break
all right,
that
yeah,
one.
we'll break
Won't
that
hurt
one.
anything.
And this is coming
It's
from
Apple.
Apple.com. And so fine. Let's assume that that's the one that is rogue, and we want to get it. The process ID right here is 12,690. You can see that from the PID column. So now all I need to do is open up Activity Monitor and look for process ID 12,690. All right. So I think these are already.
You can sort them by PID.
Yeah, I thought I did that. I guess I clicked the wrong
flip
button.
them around so you get
12,690. And look, Shazam, there it is. 690, that's right. And it's Apple Commerce Kit transaction service. Maybe I was buying something. So now we've got that. We've identified that there. We can right-click on it or not. Well, let me just terminate. Come up here.
That particular job is like a Apple monitoring service that's looking for. I mean, it's constantly checking things with Apple. So you'll see tons of this stuff on your machines, whether it's Windows or Apple or whatever it is. If you have iTunes running, if you have Google running, all these things have updaters and they have checks. They're all sitting there running, and if you kill them, then you may have to reboot your computer in between or restart those jobs. And you can also kill these jobs just by going to the command line and typing kill.
Yep.
So if you are a super user in Mac, you can type kill. Now Windows doesn't have this like quite the same way, and you have to kind of go. There's a way to do it at the command line, but it's kind of arduous.
Yep. So I would just click on the stop sign icon, octagon, and terminate, and click force quit. I'm not going to do that because I don't know.
And now I will tell you that's just step one. If you do have rogue connections, you're going to need to block those connections with a firewall because otherwise the connection may start right back up. If you have malware on your machine, you go in and kill it. Most malware, just immediately starts itself right back up. Or the next time you boot or whatever, it's just going to reinstantiate itself. And especially in Unix, a lot of these jobs will just immediately start themselves right back because if I've written a cron script or whatever kind of attack I've written, that sort of malware is going to get really, really nasty.
Yeah. And lastly, this is a good way to check to see if you've got any zombie software programs installed, because it'll constantly be going out to check like a heartbeat or whatever and see if did somebody call me or whatever.
But you have to get used to get used to it. So it's definitely something where you have to sort of start getting comfortable with what it looks like, because I've seen people just sort of panic and overreact and they jump in there and they start wiping stuff out, and then all of a sudden they can't connect to anything.
Yeah,
whatever. But again, if you do that, no big deal. These kills don't uninstall things. They don't delete things. It's just you reboot. You'll be back in business pretty quick.
The best thing you can do is if you get in and play with it, dive in and play with it. If you can set up a VM, and use it that way. That way you're not actually terminating any of the processes that you would need that are system critical,
And so next time I'm going to set up some things to show you how to capture conversations in Wireshark. So the actual capture like a video stream or something like this, you can replay it because you can actually capture the entire data stream, reassemble it, and then play it back, which is a really, really useful thing if you've got telephone calls, you've got video, you've got all kinds of music, all these things people are streaming, and you want to see what they're up to. We used to use this. We were doing cases with Sony, and people were downloading music illegally on campus, and Sony threatened to sue the university. This was not at Roger Williams, this was a long time ago, but they were going to sue us. And we started essentially sniffing our network, looking for I had to write my program. Wireshark didn't exist, so I had to write a piece of code that went in, reassembled all the traffic, so I could actually hear what they were listening to and go, oh, that's the Beatles' Let It Be. It was going to this dorm room. And then the university would literally say, yes, that is a violation. And they would send you a notice that said, you were listening to the Beatles' Let It Be. We flagged it. And that usually scared people into not doing that anymore for about 5 minutes.
Yeah. Wow.
But thanks for tuning in today. Thanks, Russ, for putting all this hard work into putting Wireshark together. And we'll see you next time.